folks. Apologies for the delay. Just getting everything up and running. We will start shortly. Okay. Cool. So, let's jump in and get things going. So last time, looks like we left off on dictionaries. Talking about the items and keys and values methods. Okay. It's kind of convenient because we covered this recently in Premium Truck. We can kind of revisit this. Sorry, I'm still still kind of getting everything set up. So it looks like we actually do have a question starting off with today. Let's actually take that. Oh, sound is a little low. That might help if I move the microphone down in front of my mouth. Let's see. Let me make sure we're on the right microphone. Okay, good. Let me know if that helped. Sorry about that. I move it up there and sometimes I forget to move it down. So we do have a question to start us off. Okay, cool. I'm glad that helped. I'll go to the link here that says, has to do with combinations Q3, not sure how to derive the formula, getting totally different result from Lance and not passing, getting numerator 15, choose 3, denominator 18, choose 5. Okay, let's take a look at this. I'll go to this link here. Let's see what's going on. Some of the statistics stuff can be kind of in depth, so I'm not going to promise like a solution on this, but I will take a look at it. Oops. Okay, combinations, question 3. Yeah, I think I know this one. Yeah, I get this question occasionally on stream. I went through and tried to answer it once, and it took up the whole stream. And I had to meet with the person afterwards anyways. So since this, if you DM me about this one, we can kind of connect about this after class offline, if that's all right. Sorry to to keep you waiting on that one. Let me see if I can. Because this ties in with the last one, if memory serves correctly. The one from permutations. Yeah, I'll have to, yeah, like I said, we'll connect afterwards. All right, sorry about that. Cool. If anybody else has another question, that one particular question is notorious, and like I said, I get it occasionally on stream, and I'm like, I don't want to make stream about this question. I think maybe we might need to rewrite that one, because it's maybe the biggest beast of a question in our material. I don't mean to make it sound too bad, but there's a lot going on. So, yeah. Cool. So I'm just going to jump into items, keys, and values, methods. Do feel free if you've got another question. Basically, if you have another Python question, I'm willing to take that on stream. Feel free to put in a link in and etc. All right. All right, so by the end of this lesson, we want you to be able to use the dot items method. Mostly this is for iterating through dictionaries, and the dot keys and the dot values method. Items, keys, and values. Okay. So we need some sort of test dictionary. I'll just grab this one here. Fruit dictionary. Apple 20, peach 15, pineapple 3. So we've got some numbers of fruits, presumably. And dot items is sort of the main tool that we use for letting us iterate through a dictionary. So if you'll recall, enumerate and zip, the way that these sort of change the way we write for loops with for sort of A, comma, B pattern. Oops. Pattern in the for loop. Right, so with enumerate we have IDX and element, right? So dot items is going to allow us to do something similar. We're going to be able to do for key value in fruit dict dot items. And we'll put on the parentheses. We don't need to give it any arguments. It doesn't take any arguments. And the interesting thing here, and this particular thing applies to enumerate and zip as well, right? So we're actually unboxing a tuple here. And we can prove that this is actually giving us a tuple back every time. I'll just call this tup. You can call this anything. We'll call it foo. How about that? And then we can just print foo. Oops. Apple, peach, pineapple. So you can see this gives us back a tuple of the keys and the values from the dictionary every time, right? So our first tuple contains the first key value pair. The second tuple contains the second key value pair, etc., right? You know, of course, first and second and third, the order being dependent on however Python chooses to optimize or chooses to return the dictionary or process the dictionary internally. But yeah, so we can basically, we can pull that apart, K, comma, V, just like this, And I could do something like there are v and then k. We'll put an apostrophe s after that. Oops. Why is there 2 apostrophes? Okay, there we go. So there are 20 apples, there are 15 peaches, there are 3 pineapples. So this is going to give me, basically just gives me access to K and V under whatever names I choose to give them. You know, A and B, usually we call it K, and V if we don't have another good name. You know, obviously if there's some obvious obvious thing to call each parts of your data, then use that name. But as generic terms, we can just use K and V or key and val, something like that. Cool. Oh, and this is a good point, actually. It's actually kind of a better way of showing this. If I just print out this, and I'll cast it as a list here in a second. Oh, actually, it does give me the whole thing, which is kind of nice. It kind of looks like it's in a list anyways, but it actually gives me a dict items object. We'll clarify its contents a little bit here. Look at it, casting it as a list first. Oops. There we go. So that's obviously what we get when we cast it as a list, and just this is to just reinforce my point earlier, you know, that we're getting a list of tuples. Right, so here's our first element in the tuple, which is the first key value pair, or the second element in the list is a tuple containing the second key value pair, etc. Right. All right. Let's see. Sometimes you want to just get just work with the keys or just the values, like only one and not the other. So if you want to deal with, let's say, one side of the dictionary, either the key side or the value side, let's do that here. We can do, let's print list. I'm just going to call this d dot keys and d dot values. And you can see we just get just the keys and just the values. So this can be pretty handy sometime. So quick note on keys. For checks for membership, if I want to say if Apple, if Apple in D, it's going to assume that I'm going to check the keys here. Not the values, not both, just the keys, right? So notice I'm leaving .keys off, but it'll check the keys. So we'll print Apple is, let's do this. I'll do fruit. And I'll say F fruit is in the dict. Fruity? Oops. Okay, so apple is in the dict, and if I say orange, then we get nothing. So you can see that this is just going to check just the keys, right? What I'll usually do in this case, if I'm doing a test for membership in the keys of a dictionary, I'll usually write out keys explicitly, just because I find that, I don't know, I just prefer to be explicit about it rather than implicit. Usually though, and I would encourage you, if you're learning, be clear about this, like write it down. It's a sort of a declaration of intention. It makes your code read a little clearer. But just know that this is more often what you'll see, and you will see code like this. A test for membership directly into a dictionary is a test for membership of the keys, right? You're seeing if fruit is a member of the keys in this dictionary. So it's just something that's sort of implied here, and you just have to know that that's the behavior. Or it's not really implied, it's just like that's the behavior. You just have to remember. Okay. Cool. Okay, so what would be the output of the below code? So we have a dictionary, we're casting it as a list, just the keys, and it looks like the keys are, oh, my dyslexia is not gonna let me read that one. Here's a comma. Dang it. Alright. Okay, so here's our dictionary, and it looks like our keys are just 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so it's just a list of 1 through 10. Correct. What is the correct way to iterate through a dictionary, assuming we want to use its keys and values? 1, 2, 3, 4. Okay, so to use its keys and values, we want to do for key val in d.items. I should mention that we actually don't need to do that. You can iterate directly through a dictionary. Just gonna get rid of that. So if I do for key in D, and this is just going to give me key. If I iterate straight through the dictionary like this, I'm only going to be iterating through the key. Or, not that, yeah. So notice I only get the keys this way. Now, this is kind of alright because I can recover the value if I do D sub k, right? So val, or we'll do v equals d sub k, and now I can print k v. So now I have access to both. So you can iterate directly through like this. It's kind of nice to have direct access to values like this. I think it makes the code a little cleaner, but you could get by doing it the other way if you wanted to. I think there's no real good reason to do it this way, but it is possible. I guess maybe the reason would be if you know that in your loop you were only going to deal with the keys and not the values at all, then I guess maybe, but anyways, what would be the output of the below code? So we've got some dictionary with the values are dictionaries of dictionaries. Oof, that is tough. Let's try this out. What a silly dictionary. Alright, so we've got this here, and I'm gonna just see if I can... Yeah, okay. So this one goes to here, and that one goes to there, and I think that that's consistent. Looks like that's consistent. Okay, that's the pattern, okay. I just needed to bring it in to make sure that I was understanding the pattern correctly. For value in d.values, print value.values. Okay, so values in d.values is going to be everything here, right? Which happen to be dictionaries, so we can call .values, and it's going to happen to give us just this. So let's see here. Option A, B, or C. Well, that's interesting because value.values. So it's either A or, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 81. Okay, so it's going to be A. So A is, you can probably see, right? It's A is the most deeply nested portion. Okay, let's say A. Now I actually want to run this code because I'm curious. So I'm kind of picking a nit here, but I see these square brackets around these, and I'm wondering if that's actually, if it's actually going to print out with those square brackets, because that makes them look like lists, and I don't think they're going to be lists. Right. So what we get is actually these dict values objects, and they would be lists if we cast them to lists like this, and that would actually give us proper square brackets. Yeah, okay. I might have to go in and kind of revamp that a little bit, put a list around that just to make it clearer. All right. Okay, so this is talking about running a loop through a dictionary, which we kind of already talked about. We can loop directly through the dictionary, like in that prior example, in this example that I gave. In this case, it's exactly like looping through the keys. So we can loop through just the keys, just the values, or the keys and the values together, which ties into what we were just talking about. Okay. So dot items returns an iterable list-like object of tuples. We can print it out directly, and we kind of saw that. We get the dict items object back, and this will give us this will give us a tuple of the dict items, right? And we could just as easily cast that as a list or whatever we wanted. Order is not guaranteed. So this is kind of a funny one because, I mean, if we look at this, it's kind of weird. Well, with this nested one, it's kind of weird. if you make a dictionary, you put the elements in the dictionary, and you print off the dictionary after you're done populating it with whatever you're going to put in it. You print it off, and you look at it, and it's the order that the key value pairs are in, the order that the items are in, are probably going to be the order that you put them in. You know, so if you put in ABC, it's probably going to come out as ABC. But that's not guaranteed, and it's not because it's not like there's a glitch or a flaw in the way that Python's designed around this. It's that that is not a feature. Dictionaries are not meant to be that kind of data type. They're not meant to retain order. So this opens the door to like being able to store that information in sort of an asynchronous way, and as long as you know where everything is, that's what's important. You don't need to necessarily know what order everything goes in. So this sounds, I think people hear this and they're like, well, why not just implement ordering for dictionaries? And like, who cares? Or that sounds like it would be a real, like it would compromise a dictionary in some way. And it doesn't really, because the value of ordering a type is basically being able to index into it. Obviously, you know, like if you're the value of ordering, for example, having order retained in a string is that the letters in the string stay where you put them, because if they were in a different order, then, you know, being a string being what it is, it would no longer be meaningful if the order could come out in any way, you know. So but dictionaries are not strings. They're not used in the same place that strings are. You know, they're not used to represent text, right? So they're used to represent different kinds of information. So ordering really isn't that important. It's not important in the same way that it is with a string. What is important is that you have some mechanism, in this case a key, to retrieve values back from. And somebody always asks me, like, well, what if you know the value of a dictionary and you want to know what its key is? If you know a value in the dictionary and you don't know what its key is, you can't reconstruct that. It's like, yeah, that's just not something a dictionary will do. But if you know the key, you can access the value at that key. So it's sort of a one-way street. So the key, again, the key really just replaces the index in a list or a tuple. You know, what I'm saying is, whereas lists and tuples have indices, dictionaries replace those indices with keys. Okay. Oh, there's a little typo there. That should say .keys function with an S behind it. Okay. Dictionaries as accumulators. As with other built-in data types in Python, the dict type can be used as an accumulator. Consider the function below that unpacks a list of tuples into a dictionary accumulator. Okay. So we have our list of tuples, and what's interesting about this, I can actually cast this as a dictionary just like this. So a dictionary can take any data that's kind of shaped like this from indexed types and turn it into a dictionary. So basically this is a two-wide matrix. So any two-wide matrix can be turned into a dictionary like this. And when I say two-wide, what I mean is, you know, you can see I have 1, 2, 3, 4 rows. So that gives me the height, if you want to call it the height of the matrix. And then the width of the matrix is how many columns I have, right? And each one has 2, right? So if you have 2 columns, if you build a matrix like this and you have 2 columns, you can cast that 2-column wide structure as a dictionary. And this would work for a list of 2-wide lists, or a list of 2-wide tuples as shown here, or a tuple of 2-wide tuples, or a tuple of 2-wide lists, right? So whether the inner or outer type is a list or a tuple doesn't really matter. It just matters that it's a 2-wide matrix. So all of those would be ways of describing 2-wide matrices. And we can just cast it that way. But this is giving an example of a way of doing this through an accumulator, right? So we just start an empty dictionary, for tup in the list of tups, d sub tup sub 0 equals equals tup sub 1. Let's see. And then this just returns the dictionary. So this is actually going to do exactly, it's going to behave exactly like the dict function in this case. Cool. Looks like we got a question. All right. Here's a question. And we'll go to the link. This is about breaking loops. Getting my words confused. Okay. So challenge 3, not sure how to create this function to accumulate prime numbers in a separate list. Cool. Find primes. So complete the find primes function according to its docstring. So a big secret with this one is to write an isprime function. It's you can do the isprime logic in line. It makes it harder to think about. I think it's cleaner code if you do it as a separate function. And what you end up with is 2 relatively simple functions rather than one kind of complicated function. So yeah, let's take a look at this. So finds all prime numbers in a num list and returns those primes in a new list. So basically, it's funny because I do something. This function is really similar to what I do to actually test when I write an isprime function to actually test the function, and I'll show that in a second here. But let's just test this function. It's kind of funny because this is usually effectively my test for the isprime function. So so we'll have a we'll pass out a list of 4, 7, 0. You know what? This would just be easier if I just did 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Yeah, we'll just cut it off at, we'll cut it off at 17 there. Okay. we'll say my list, and I'll say my list equals this. And some of you might be wondering why I don't just do my list equals list range 20, or this is actually going to go up to 18. There's no good reason. I just wanted to keep it like written as a list so it was clear that there wasn't any magic happening with the range or anything. So 6 of one, half a dozen of the other. I'm just writing them all out and being explicit. You could do it the other way, and I usually do. So find all the prime numbers in numList, return those primes in a new list. Okay, so given this list and this function call, I should see a list returned containing only prime numbers. So that's going to be 2, 3, 5, 7, 11, 13, 17. There we go. So this is what I should see. And let's do something like this. Res equals this. Exp for expectation. Res is short for result. Exp is short for expectation. At least the way I'm doing this. And we'll print res, comma, res equals exp. Let's do this. Res exp, and then res equals exp. So this will show me the result that I actually got. This will show me the thing that I expected to get, and this will show me true or false whether they're equal or not. Of course, I'll be able to see it pretty easily, but just figured I'd show just a little alternative for some testing stuff. Always good to pick up stuff around that if you can. Okay, so for this, I could just do we'll have an accumulator list. I'll call it list is an empty list for num in num list list dot append num. Oh, excuse me. We'll do this. If is prime num. So if the number is a prime number, then we'll append num and then return list, right? So the only problem with this solution is that I don't have an isPrime function. Now, like I said, I could do this logic in line here, but I'm going to solve it with an isPrime function, and then we'll look at doing it in line and see what that entails. So right now, as it stands, if I had an isPrime function, this is a very simple function. If I can just tell true or false as to whether a number is prime or not with a function like this, which fortunately writing such a function is not that hard. So we can say def is prime, we'll take in n, and I'm just going to say if n is less than or equal to 1, return false. And we can say if n mod 2 equals 0. I'm going to do some optimizations on this just for fun. If n mod 2 equals 0, we'll return false. Oh, excuse me. Yep. So in this case, we can just turn this into an or n mod 2 equals 0. Now we need to see if n equals 2. We actually need to do this one first, because 2 mod 2 is 0. So if n equals 2, that's the only case where we're going to return true. So this is an edge case of this other edge case, which means we need to check it first. Okay, so these are my edge cases, and then I'm going to say for I in range, we'll do 3 to in I'm going to cast this as an int. We're going to include it, so we'll say +1, and I'm going to do the square root of n, which is n to the power of 1/2. And then we're going to take steps of 2, and that'll be a nice efficient isPrime function. So here I can just say if n mod I equals 0, then we know I is a factor of n, and we can return false. So if I is a factor of n, we know it's not a prime number. If we make it through that loop and we've checked all those values for I, we can return true. Cool. So it looks like this is working. So now in order to submit this in learn, oops, I'll just copy that there, paste it in, and we'll see. Hopefully I got it. Nope, I sure didn't. Def isPrime. Did I like mess something up? Oh, break not found. Oh my gosh, they got me. It literally has to return break. Has to have the break keyword. I wonder if I can just while true break. Ha! Okay, I just wanted to cheese it. I'm totally cheating here, and I'll make no excuses for myself. I'm absolutely cheating. So I solved the problem in a way that obviously goes against this being in breaking loops, and I'm quite certain that this problem didn't use to detect this, but now evidently it does actually literally look for the break keyword being part of the solution. So I was like, okay, well I just need to put a valid break in, which means it just needs to be in a loop somewhere. So I'll make a while loop that I'll immediately break, and this satisfies that constraint. So the reason that I wanted to show it this way is because, you know, like if you were actually writing this solution, this is the way to do this. And it's not just this solution. Most of the time that you end up needing break, you can get around it. And I'll show a break solution as well. So the way that I'm getting around using break here, and gosh, you know, I actually should write a simpler, you know what, I'm going to write a simpler, I'm going to simplify this. It'll be less efficient, but it'll be easier to deal with. So this whole, I'll keep the square root part, and we'll get rid of that. Start at 2 there. Okay, so with this function, what I'm doing, I'm saving myself some time with this return. This return is a de facto break to the loop, because it doesn't just stop the loop, it stops all code execution in the whole function. It just, when the interpreter encounters a return, it's just over. Like there's no more code execution that's going to happen in that function. So yeah, so a return is a sort of a de facto break. And I wanted to showcase this first to encourage this kind of thinking, right? The way you think about most problems, you're going to be breaking things out into their own functions basically whenever possible, whenever it makes sense to do so. So if we look at this, this is a fairly simple function on its own, and we look at this is a fairly simple function on its own. Neither of these is wild or outlandish to understand. The one kind of tricky thing here is this like square root of n thing, which we could actually even simplify this to just n, which is going to make it much less efficient, but it'll absolutely work. So either way, however we end up writing the isprime function, it's not terribly complicated. And then this is just downright simple. If we have it in line, things get a little more hairy. So let's kind of look at this. I'm gonna reuse isprime, but I'm gonna make isprime a variable instead. So we'll do a Boolean flag control here. So we'll say isprime equals, what do I want to do? I think I'll do true. Start it off at true. You can kind of guess at this, and then the logic will probably become clear, like where you should start it later. But from here, I'll basically just copy this code. I'll give myself some space here, just to be clear. Okay. So this return true is what gave the prior, the isprime function, the value wherever I evaluated it. So isprime is actually doing that here. So I can just get rid of that. And then this return false, for these cases, we'll say isprime equals false. So if n is less than 0 or 1, we'll do that. And then for I in range blah blah blah, we'll say isprime equals false. And we'll break this loop, break, like that. Okay, I think that's right. N is not defined, right, of course. So I used num here. So num is my input into this system. Num, let's try that. N is still not defined. We still have another n in here. I gotta get them all. Num. N is still not defined. I still get another one. Where is it? Oh my gosh. Okay, there we go. So this works on its own. So this is, I guess this isn't terribly complicated either, but it's, you know, it's got a nested loop in it. It's starting to get to the point where it's like there's some bulk to this code. There's some like there's something about it that's not as easy to deal with. It's not as easy to read. It's just kind of got, it feels and looks kind of messier to me. Oops, let's just do that. So this works, okay. So the reason that we have this break here, the funny thing is, the break's not even necessary. It just saves us from unnecessary looping, and it would be more useful if we, you know, if we did 2 to n like this, because it just means that we're not going to check any extra numbers that we don't need to check, right? So yeah, so breaking is just going to stop this inner loop, and this is, see, now it's kind of hard to tell, right, like where, oops, where the, like one part of the function begins and the other one ends, but this is our, basically our isprime function logic in between these bars here. right? So this loop is used to determine if a number is prime or not. And as soon as we find a factor, we know we don't need to go on continuing to check to see if there are more factors. We can just stop the loop right there and break. So that's the whole thing there. Cool. Hopefully that's helpful. Let me know if that works. Yeah. Anyways, okay. And they did this, in fact, a third way where they did a Boolean flag controlled isPrime function as a helper function. And same deal. So they use break in the main loop for the isPrime function, and then continue on. All right, cool. You're welcome. Cool. All right, I'm not seeing any other questions. Y'all do feel free to bring in your questions, post them in anytime you've got them. Oops. Sorry, just checking the streaming. Sorry about the low resolution. I'm still trying to get that all hashed out. I think I need to just like sit down and spend a few hours on it over the weekend and do some test streams and like get a friend to help me verify the streaming integrity. Anyways. Okay. Cool. So let's get back to some of this stuff about dictionaries. We were talking about traversing a dictionary. I think I kind of went over this. There's a word count dictionary. All right. So what is returned when the dot items method is called on a dictionary? A list filled with list-like objects. Not really. A tuple filled with list-like objects. A list-like object filled with list of length 2. A list-like object filled with tuples. I guess? Yeah. Write a function called reversedict that takes in one dictionary as a parameter and will return a new dictionary that is the reversed version of the past dictionary. That's weird. Okay. This is one of those things where this is the conversation about dictionaries being ordered is strange. We don't think about them as an ordered type, and sometimes they will come out in different orders, but there are certain cases where they'll retain an order, and this question is banking on that for some reason. So I don't know why, but whatever. We'll do it anyways. So write a function called reversedict that takes in one dictionary as a parameter and will return a new dictionary that is reversed version of the past dictionary. Oh, I misunderstood. By reversed, we mean that the keys of the past dictionary become the values and the values become the keys. Yeah, okay. I was like, what is going on here? Okay, def reversedict. This will take in dn, and I'll just say d equals empty dict 4k v in dn dot items d sub v equals k. Return d. Okay, that should do it. So this just flip-flops the keys and the values. I'd probably like name that like flip-flop dictionary or something, but I don't know. All right. Write a function called findvalue that takes two parameters. The first parameter called searchdict is a dictionary. The second parameter called val to find is a specific value to find in the dictionary. If the value is a dictionary, it should return a list of the corresponding key or keys if the value occurs more than once. All right. If the value is not a dictionary, it should return da-da-da. Okay. Function called findvalue. So def. Whoops. That'll take in two parameters. Searchdict and val to find. So let's do that right there. Okay. So searchdict and val to find sum d equals okay, so let's do this. I'll just do the car dictionary. Make Toyota model Camry and year 2030. Okay. There we go. Sorry, I'm just being a little pedantic here. There we go. That's better. And then some val will be, I assume, a value. So let's do 2030. Okay. Write a function called da-da-da. The second parameter val defines a specific value to find in the dictionary. Okay, so we're looking for a value, it sounds like. If the value is in the dictionary, it should return a list of the corresponding key or keys if the value occurs more than once. If the value is not in the dictionary, it should return the phrase, that value does not exist. Well, that one's an easy one because we can just do a test for membership. If val to find not in search dict return that value does not exist. Otherwise, we're going to do list equals empty list for I in range, sorry, what am I doing? For k v in search dict dot items if k equals, nope, if v equals val to find, that'll be list dot append k. Oh, return list. We got single equals, I meant double equals. The value does not exist. Okay. Interesting. Very interesting. Oh, so I'm doing this test for membership, and I just forgot the rule that I was just talking about mere moments ago. I'm seeing if val-defined is not in the dictionary. So val-defined is a value to check if to see if the it's a value of one of the keys in the dictionary. This kind of test for membership tests keys. So this is why I always write keys. I'm out of that habit. I say I always do it, and then I think I'm out of that habit. I used to always do it. I need to retrain myself to do that. So this time I'm going to check values. And, oh, values like that. Okay, so year, good. And then, I don't know. Let's see, something, 2030, okay. Cool. All right, cool. Removing dictionary keys and values. Cool. So there are two tools to do this, del and pop. Okay, so I'm just gonna take this dictionary again, and basically, if you're familiar with pop for lists, it works similar for dictionaries, right? Whereas pop takes an index for a list or a tuple, or excuse me, it doesn't exist for tuples, whereas it takes an index in a list, if you're calling it on a list. Dictionaries don't have indices, they have keys instead of indices. So this, we would need to take the keys, something, and then let's print our dictionary down here. And you can see we have that something key removed, right? If I try to get a key, some key like this, we're going to get a key error. So this is just telling us again, best practice is check for membership if some key in some d dot pop some key. In this case, it's not a member there, so it won't take it off. So let's take off year, so we can do that. And just like pop with lists, pop returns the value associated. For a list, it returns the value associated with the index. For a dictionary, there's no index, so it returns a value associated with the key. We'll call this res, and I'll just print off res as well. So 2030. Cool. So what is the proper way to make a dictionary initial, wait, to make a, what? Oh, okay, so I think this is just a typo. I think that dictionary doesn't need to be in there, so I think this is meant to say, what is the proper way to make the initial dictionary look like the result dictionary? So initial and result, we could pop dot other, I guess we could do it like this. Okay. I wonder if is dot pop also a good option? I guess we don't need to do dot pop because we're not returning a value. So I didn't cover del because I think you tend to see dot pop more. I don't know. I don't really know. But let's look at del as well. So the del keyword, del, if you're familiar with that, is short for delete. And it'll just delete whatever you tell it to delete. So I could del some I could delete the whole dictionary, and if I try to access it, print it off, it's going to give me a name error as if it never existed. That's the same error that I would have got if I had never created it in the first place. You know, if I just do that, some D is not defined. Some D is not defined, right? So it'll also delete a specific key value pair, right? So if I did model, you can see it would delete that key value pair. So I'm guessing that that was the proper way to do it because, like I said, pop returns a value, and since we don't need to return that value here, I guess we can do del, but I don't know. Like in either of these cases, you have to know the key that you want to delete from. So pop also returns a value. So to me, it's like just use pop, and it just keeps the set of things that you use sort of smaller and more consistent. But del will just delete, and you won't, like I can't do like res equals this and expect anything to happen. In fact, that'll be invalid syntax. Anyways. Okay. Write a function called try to remove that takes 3 arguments: test dict, test key, and pop. So we'll just do this. Test dict. Oh no. Oh, really? Dang it, okay. Pop. I'll bring this over here. Okay, so this function should check to see if test key is in test dict. If it is and pop is true, the function should pop the value. Okay, let's do this. Copy this in. I need to break this one up. Okay. The function should check to see if test key. I'm just going to turn these notes into Python. So if test key in dict and pop equals true. Like this. That's just Python code now. Okay, so the function should pop the value from the input dictionary and return it. So I don't know if it means return the value or return the dictionary. If test key is in test dict and pop is false, the function should simply remove that key value pair from the dictionary. If test key is not in the dictionary, the function should return key not found. So I'm going to do that one actually first. If I'll do this. Okay, so if test key not in test dict, return key not found. Okay, so that's sort of my most edge casey edge case. This is just kind of a function of all edge cases, but that's my edge casiest one. So we'll just get that out of there. So everything below this line, we can assume that that test key is in the dictionary, which is kind of nice. So if that's the case, we'll return key not found. Now we just need to see if pop is true or not. So elif pop is true, and since pop is, do we have a default for pop? I don't think so. No. Pop is going to be a boolean, a parameter named pop whose default, oh, we do have a default, so right, so pop will either be true or false. So I can just say elif pop, then I'll say return now. From the way this is written, I'm not actually sure if it wants to return what pop returns, or to pop and then return the dictionary after we popped from it. But that wouldn't really make sense. This is going to mutate the input, which we don't want to do. So I'm just going to copy it out of the gate. Hopefully that's okay. Else. Return test dict dot pop. I think we'll just do this. We'll get that there, and then up here I'll say this. So else test dict dot pop test key, and then we'll return test dict. So I could use del here because I'm just using it as a remove operation. So we'll see if this works. I'm kind of expecting an error because I'm not entirely clear about what this behavior is expected here. And maybe that's because I didn't read the problem all the way or good enough, but we'll see. Oh, I got it. Hooray. Cool. And like I said, sorry, I just realized this is very small. Let me make that a little bit bigger. Drag this around real quick. Oops, no, not hide it. Just move it. Just move it around a little bit. There we go. Okay, right there. Okay. this a little smaller. Cool. So anyways, like I was saying, I could use del here to delete this key. Del, like that. Doesn't really matter. Cool. All right, well, we got one more in here. It is our normal stopping time. This is the normal time where we wrap up, or I wrap up study halls. And it's Friday, so I think I'm feeling done for the day, and I'm sure y'all want to get on with your weekend. So you all have a good rest of your weekend. If you're in premium prep, you'll be working with Tovio tomorrow in class tomorrow at noon, Saturday. And I'll be teaching premium prep on Monday, and I'll be streaming again on Monday with study hall as well. Please feel free to reach out, and if you have any questions, you're welcome to use Slack as a resource. You can post in the basic prep or in premium prep channels, and use the community as a resource. Basic prep is fairly active, and it's a good place to ask for help. If you want to ask for help from me or from one of the other instructors, you can do that too. Just send us a DM and we'll get back to you as soon as possible. Cool. So I'll wrap up there. You all have a good rest of your day, and I'll see y'all on Monday. Bye-bye.